Hello everyone, I'm Dr. Rajesh, and in this video lecture we will study uh, Newton's divided difference formula and will do its proof. So in the examination it could be asked that state and prove Newton's divided difference formula. This is very important question from examination point of view. So firstly we have to write its statement. So how will its statement go? Its statement will go something like, I am explaining here, let fx be a polynomial of degree n, fine, and it assumes values f of x naught, f of x1, f of x2, 3 dot, and then you will write f of xn at unequally spaced arguments x naught, x1, x2, xn respectively. So here it is worth mentioning that these arguments x naught, x1, x2 up to xn, these are n plus 1 arguments because it is of degree, and so we have to have the values of the function given at least n plus 1 points. So this is given at n plus 1 point. So now these n plus 1 points x naught, x1, x2, these arguments are not equally spaced. So then what does this Newton divided difference formula states that? It states that the value of the function is given by, it will be f of x naught, x minus x naught, it will be f of first order divided difference, f of x naught, and below this you will write x1 plus x minus x naught, x minus x1, second order divided difference, you will write square f of x naught, and below you will write x1, x2, one more term I am going to write x minus x naught, x minus x1, x minus x2, and it will be third order, and you will write x1, x2 and x3. Similarly, continuing likewise, you put 3 dots, you will write the last term, that is nth order derivative, nth order divided difference. What it will be? It will be, here is 2, look, here is 1 less, up to 1 less, here is 3, here is up to 1 less. So whenever here will be n, so here will this product terms will go up to 1 less, and 1 less than n is nothing but up to x minus x raised to the power n minus 1, and here will be n. Below you will write x1, x2, 3 dots, xn. So this is the Newton divided difference formula. Now we will prove this formula, and when this formula is used when the intervals are unequally spaced and values of the polynomial of degree n is given at n plus 1 points, unequally spaced point. So the value, in that case the function f(x) will be given by this one, and this formula will be used to interpolate the value of the function when the arguments are unequally spaced. Now we will be driving and we will be doing its proof. So in the proof you will once again write that f(x), these things you will write f(x) be polynomial degree n, and it is assuming the values, these one which are at the arguments which are unequally spaced. So in this case I am going to take the first order divided difference, that is first order divided difference, and it is f of x naught. One, I have taken x, the variable quantity, x naught is a point at which the value is given, so one is variable and the other is constant. So how you know how this value is given by, it is given by divided difference. I am going to this as first f of x minus f of x naught. I have already given you the definition. The difference can be taken between the initial and final point, or final, what you could also write it as this one. It is up to you. I have already told you this could be written something like, okay. So for the time being I am going to remove it from here. So I have written it something like this is first order divided difference. So I am going to multiply it over here. This will go over here and this will come over there. This implies that we will get f of x will be f of x naught plus x minus x naught f of x naught. Now can we stop over here? We have to determine f of x. Okay, it has come here, this one. But you see, in the, this is first order divided difference, second order divided difference, sorry, it is first order divided difference, and you see here the argument, one of the argument involved is a variable quantity. This is a variable quantity, so we don't need the variable in the final expression. So it is very much confirmed from here that this is at least not the final result. We need to do some more exercise and we need to remove this variable. As far as this variable is present, we cannot stop. We need to do the exercise more and more so that we could remove this variable quantity. So what you'll do, you will try to remove this the variable quantity, and to remove this variable quantity I am going to name it as equation 1. I have no option but to move to the second order divided difference. So we'll move towards the second order divided difference. So I will write here the second order divided difference. You know, it will given by f of x, the variable x naught, and x1. Fine. How will you write? You will write, you know, first two and the last two. You know the formula. So firstly I am going to write the first two because here I have written the initial point and then the final. So I am going to write the first two, f of x naught minus f of x naught x1 divided by difference between the extremities, and here I am writing this one. Fine. So now we have to find value of x comma x naught, first order divided difference involving the variable. So I will keep it over here. This will multiply, go there, and we will take it in the left hand side. So this implies that f of x naught will be f of x naught x1 plus x minus x1 f of x naught x1. Fine. So you have no option but to make it as 2. Use 2 in 1. This is second order divided difference. You could write it over here, second order divided difference. Fine. Now use 2 in 1. What you'll get? Here is 2. I'm going to use in 1. So you will get f of x is equal to f of x naught, fine, plus x minus x naught. So here are the curly braces, going to put this value x naught x1 plus x minus x1 f of x x naught x1. You have to use the curly braces. This is equal to f of x naught plus x minus x naught. Now you will multiply inside, it will be f of x naught x1 plus it will be x minus x naught into x minus x1, x minus x naught into x minus x1, fine, and it will be x naught x1. So you will see that we have determined fx up to here, but here still the problem is the same. This is second order divided difference, but the variable involving here is x, which is a variable quantity. So you couldn't have the variable involved in any of the divided difference, but here in the second order divided difference, when we did the whole exercise, the variable x is present. We need to again remove it, so we have no option. We have to move further because we cannot stop. Here x variable is involved, so it is very much clear. It is indicating itself that we cannot stop here. So I have to move further. So to move further, we will be moving toward the third order divided difference, and as of now I am going to mark this equation as equation number 3, and will be moving smoothly towards the third order divided difference. So here we will be moving toward third order divided difference. So what will be the third order? You know, it will be f of x, x naught, x1 and x2, fine. Now this will be first 3 and last 3. Okay, I am going to write the first x, x naught, x1 minus x naught, x1, x2 divided by the difference between the extremities, that is x minus x2. This will go over there because we need its value. It is over here, so this will go there and this will come in the left hand side. We'll get f of x, x naught, x1 is equal to f of x naught, x1, x2. It will be plus x minus x2, fine, f of, it will be f of x, x naught, x1, x2. You are going to name it as 4. Now you going to use 4 in 3. Using 4 in 3, we get, now what we'll we'll get f of x is equal to f of x naught, x minus x naught, f of x naught, x1 plus x minus x naught, x minus x1. In the curly braces you will write this expression f of x naught, x1, x2 plus x minus x2, f of x, x naught, x1, x2, fine. So now you will multiply this inside, you will get f of x is equal to f of x naught x minus x naught f of x naught x1 plus x minus x naught x minus x1. This will multiply with this one, x naught x2 plus this will multiply inside x minus x naught x minus x1 x minus x2, and here will be f of x x naught x1 x2. Okay, so this is the result when we have taken the third order. In the third order divided difference, we have got x, besides x we have got x naught x1 x2, first three. When we will take, so we take n plus 1th order divided difference. So you must ask that why you are talking about the n plus 1th order divided difference as the last step, because we know that the polynomial is of degree n and n plus 1th order divided difference would be 0. So here if we continuing likewise, if I write continuing likewise, if we take n plus 1th order divided difference and put that value in its preceding obtained equation, then we get, what will we get? You look here, this was the result obtained by putting the third result from third order divided difference into preceding equation. And what is the result? First three and the beside these first three, here is x. So whenever here will be n plus 1th, here will be first n plus 1 quantities and x. So I am going to write the result. It will be f of x equal to f of x naught plus x minus x naught f of x naught x1 plus x minus x naught x minus x1, and here will be f of x naught x1 x2 plus so on. You will go on something like that. If you want to write the next term, you could write x minus x naught x minus x1 x minus x2, and it will be f of x naught x1 x2 x3. Okay, here is 3. And what will be the last term? It will be, here is up to 2, so here is x minus x2. So here are first n plus 1 argument and beside this x. So firstly I am going to write this term. It will be x x naught x1 x2 up to xn. These are x naught to xn are n plus 1 terms, and beside these n plus 1 term there is x. Fine. And what are what about those product terms? Look, those product terms are up to, here is x naught x1 x2 xn. So here was x naught x1 x2, here is x naught x1 x2. So the product term will contain x minus x naught x minus x1 x minus x2 up to x minus xn. Fine. So this will be the last term containing the variable quantity. And if I want to write its preceding term, how will see what was its preceding term? Omit x from here. Omit means remove x from here, write it as a only constant quantity, and 1 less than of x2. Here 1 less than of x2, that will be x1. So if I write its preceding term, it will be x minus x naught. Firstly write this f x naught, omit this x, remove this x, and write the other term as such, x1 x2 up to xn, and in product it will be x1, x minus x2, and one less, x minus xn minus 1. So it is in the product, and you will write here 3 dots, so you could know that it is going on. This is the second last term, this is the last term. You see, this is containing n plus 2 arguments, so this is n plus 1th order divided difference, and we know that n plus 1th order divided difference is always equal to 0 if fx is a polynomial of degree n. So you could write, since fx is a polynomial of degree n, therefore n plus 1th order divided difference will be 0. This implies that f of x, x0, x1, x2 up to xn will be 0, and you are going to name this equation. And what was the last number? Can we see 4 is the last number, so I am going to name this equation as equation number 5. So put 6 in 5, what will get? I am going to use 6 in 5, we get, you will get f of x is equal to f of x naught plus x minus x naught, f of x naught, x1, x minus x naught, this term, x minus x1, f of x naught, x1, x2 plus x minus x naught, x minus x1 into x minus x2, f of x naught, x1, x3. Okay, fine. Plus it will go on something like this, would become 0, so this will be the last term, and go on something like it will be x minus x naught, x minus x1, x minus x2 up to x minus xn minus 1, and it will be f of x naught, x1, x2, xn. So in different notation, we know this is first order divided difference, so this can be written as f of x naught, this will be x minus x naught, and it will be first order divided difference, so it can be written something below, you write x1, x minus x naught, x minus x1, this is second order divided difference, so I am going to write it as f of x naught, and here you will write the both arguments except x naught, that is x1, x2 plus x minus x naught, x minus x1, x minus x2, and here you will write third order divided difference, that is x naught and x1, x2, x3 plus and so on. The last term will be x minus x naught, x minus x1, x minus x2 up to x minus xn minus 1, nth order divided difference. Here will be x1, x2 up to xn. So this is the required formula that we need to prove. So this is a Newton divided difference formula used to interpolate the value of the function f(x) when the value of function is given at n plus 1 point at the arguments which are unequally spaced, So this is what we were required to prove. Okay, this was what we required to prove, and this question is very important from examination point of view. You must go through this question very carefully. So that's all I have from this lecture, and if you like the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye, take care, bye bye, and see you soon.